Example 2. Earlier in this course, you were invited and had the opportunity to participate in the earphone testings. Is there a difference in the sound clarity of the sound swap blue earphone and the other earphone in the market at the 5% significance level? So first step, you ask 2 questions. Okay, so which situation you're in and which testing you're dealing with. How we know which testing we're dealing with is we look for the keyword difference. So therefore, we know that we're looking for two-tail. We're looking for, are they the same or are they not the same? And how we know which situation we're in, how we know this is a pair sample, is we need to look at the data. When we look at the data set, we have one column of data for the sound sort, sound clarity, and then we have one column for the other earphone sound clarity. And we look at the count. When we look at the data size, we know that we have 144 students. So these are actual students filling in the survey that have collected over a couple of semesters. How we know this is pair sample is because when we look at the sample size, N1 equals to N2, we have both of them, N1 equals to N2 equals to 144. And we know that they're the same person filling in the surveys. So when the student conducted the survey, what they did was they listened to the song once using the sound swap blue earphone, and then they fill in a score. And then they listen to the same song using the other earphone in the market, and then they put a score for that. So we know that they're the same person doing the survey, and then the same sample size is the same. So therefore, we know that this is pair sample. So once we have done step 1, once we know which situation we're in and which testing we're dealing with, then we can go to step 2, which is identifying the H0 and H1. Okay, so we're dealing with pair sample, and then we're dealing with two-tail testings. So therefore, we know that for H0 is mu d equals to 0. H1 is mu d does not equal to 0. And then we put that into the H0 and H1. So mu d is the difference between sample size 1 and sample size 2. What we're saying is that we want to prove that for H1, we want to prove that the difference, the mean difference, the mu difference, the mean difference does not equal to 0. So we want to prove that they're different. And then before we prove that, we have to assume that the mean are the same. So that's what we have in the H0. And then once we have identified the hypothesis testings, then we go to the next part B. We compare the test statistics with the critical. And then the formula for test statistics, I give it to you here. The reason this is T statistics is because we're dealing with sample size, right? We don't have any information about the population standard deviation. All we have is the sample standard deviation. So that's why we know this is T distribution. And when we look at the formula, we have D bar minus the mu D divided by sample standard deviation divided by square root N. I'll show you how to get the D bar, and I'll get you how to get the SD, sample standard deviation, from the Excel file right now. So to calculate the D bar is the average of the difference. What we need to do is first calculate the difference for each person. So we have, for person 1, we have B3 minus C3. So we calculate the difference for the first person. And then we need to get the difference for each person. So we need to replicate this formula. And how we replicate this formula is bottom right corner. You see the black cross. You hold it and then you just drag it down. And then Excel will calculate the difference for each person. So once we calculated the difference for each person, then we can calculate D bar. So D bar is just the average of the difference. Equal average. So we take the equal average, and then we highlight the data set to get the D bar, the average. And then we do the same for standard deviation, sample standard deviations. This is sample size. So we use equal STDEV.S to get the sample standard deviation of the difference. And we know that the sample size is 144. How we know that is we use the formula equal count to calculate how many sample size we have for the difference. That's how we get the D bar, the sample standard deviation, and the sample size. Equal average, equal STDEV.S, and then equal count. So these are formula that we have learned already in chapter 3. Once we have calculated the D bar, once we calculate the sample standard deviation and sample size, we plug it into the formula to get T statistics. We're going to get 5.89. And then we compare that with the T critical. To calculate the T critical, we use T.INV, and then we know this is two-tailed, so we use alpha over 2 and then 1 minus alpha over 2, so 0.025 and then 0.975, and then degree of freedom is n minus 1, so 144 minus 1, so it's 143. We're going to get negative 1.98 and 1.98. So once we have the statistics in critical, we compare them in absolute value because this is two-tailed, and we know that statistics is greater than critical, so therefore we reject H0 except H1, except that the mean difference does not equal to 0.